So that brings us back to number 21, which even on the test hints, it says this is similar to question 20.
Right.
And again, focusing on how that metallic bond is formed. And you have these electrons, these valence electrons, that are evenly attracted to any other nucleus they happen to come by. So
Right.
those electrons are actually free to move around inside of a solid piece of metal. So it's the electrons are free, you have a delocalized, which means they're free to go wherever they need to, wherever they feel like, through a solid piece of metal.
Awesome. Okay, number 22, describe why metals are good conductors. Well, for the same reason, that sea of delocalized electrons. Those electrons are negatively charged particles. And electrons bumping down a row there are what creates an electric current. It's what an electric current essentially is. So if those electrons can move, then the electricity can flow through that, and we've got a whole bunch of electrons available to do that. So that's why metals are such good conductors.
That's exactly right. Number 23 is, again, I show up at the define questions. Define alloy. This again goes back to metallic bonding. It's in the book. Look it up. It's a mixture of metals, and the way they make that is basically in the molten state. They mix together liquid forms of different metals, create a homogeneous mixture, and then allow that to cool. And you end up with metals like steel that have different properties. And the kind of steel that you use to make nuts and bolts is not the same kind of steel that they use to make surgical tools out of.
Right.
It's a different recipe of lots of different chemical elements.
There's all sorts of different alloys. The brass that
Right.
makes band instruments.
Doorknobs.
Yeah, the alloys that make airplanes, all sorts of stuff.
Right.
And they mix together different metals. Remember, it's mixing them together because they do have better properties.
Yeah.
Maybe they're stronger, or maybe some are easier to draw into a wire, depending on the use.
Right.
That would be important. Number 24. We'll let you do this one since you had all the identify.
Great. Identify the transition metal ion, or identify which transition metal ion would have a color. And going back to Lab 10, taking a look at all of those different solutions, the transition metals, again, they're doing all kinds of crazy things with their D sublevel. The transition metal ions that have incomplete D sublevels are typically colored.
Right. Because I guess going back to one of those properties that we were trying to think of, well, what's the other property of an ionic solid? Most of them are white.
Yeah.
But some of those ionic compounds can be brightly colored
Yeah.
and beautiful. That's what makes some gemstones and things too.
Sure.
But like Mr. Sustin said, it's the one that have incomplete D orbitals. So if it's ending on like D8, nickel
Right.
tends to be green.
D6, iron can be yellow
Red or brown.
or reddish orange. Some of the chromium compounds can be a real vivid orange and green and things like that.
All sorts of things.
Yeah.
All right, and that takes us to the short answer questions. And number 25, the hint says, write an electron configuration for an ion. We're actually going to tell you exactly what ion we want you to write the configuration of. And if it's a positive ion, then you are going to need to take away the outermost electrons. And if it's a negative ion, you're going to need to fill in. If we say it is a +2 ion, then you're going to need to take away 2 electrons from the atom's normal configuration. If it's a -3, you're going to have to add 3 to the end and end in P6.
Right.
Alrighty?
Number 26, write an electron configuration for an atom and its ion. So now we need to make sure that you're correctly identifying which electrons needed to be removed or where those electrons needed to be added.
Right.
So you have to be able to write out both.
Right.
the neutral atom, and then the ion.
Right, so we'll just give you the name of the element, and you're going to have to figure out, well, is that metal or is it non-metal? Should it lose electrons? Should it gain them? And then write the correct configuration for both.
Right.
Alrighty, 27 is similar to 25, so again, we're going to give you the name of an element, and you are going to write the electron configuration for its common ion. 28.
28, yes. Describe with a picture an ionic bond, highlighting the crystal lattice structure. So I would definitely make sure that I'm illustrating positive ions being attracted to negative ions. And you might, because it says in here crystal lattice structure, you really ought to repeat that property or that illustration and show how these ions sort of build on each other in space. Just drawing one positive ion next to a negative ion, that really doesn't satisfy the crystal lattice part of this question. So you're going to want to represent something that looks a little like that.
Okay, my drawing wasn't all that hot, but we have smaller ions, and what charge would the smaller ions have?
Smaller ions, I wish I had a nerdy student handy. The smaller ions are going to be the positive ones. The negative ions are going to be the larger ones. Dedicated, motivated students would label to emphasize that they really do know what they're talking about. And
Could even give us an example. So maybe the Na+1 ion and the Cl-1. I should have done that in green since chlorine's a green gas.
Right. Dedicated, motivated students are also going to show or somehow illustrate the transfer of electrons. Sodium lost an electron, chlorine gained one. It would be nice to show maybe how that happened.
You know, if they watch the animation, the one with the fisticuffs, there's fisticuffs, then they know all about what was happening, the battle that went on.
There you go.
And we'll see who paid attention.
Right.
Number 29, describe the crystal lattice structure of the ions in an ionic bond. Well, if you have a wonderful drawing for this one, you should be able to easily use that as your example for the next question. And it's important to know that these are alternating. Why didn't I draw that with all the positive ones on this side and all the negative ones on this side?
Because you're smart.
Yes.
Because remember, it's the oppositely charged ions are attracted to each other. Like charged particles would really rather not be packed that closely to each other.
Right.
So you get a negative ion, and surrounding it would be positive ions.
Right. So those charges cancel out.
Right.
And woohoo, the last one.
Last one. Describe what happens to an ionic compound in its liquid state that causes it to become a good conductor. An ionic compound in its liquid state. Does that mean dissolved in water?
Well, it could be melted.
Yeah, they're talking about a compound in its liquid state. When you melt an ionic compound,
Which takes a lot of heat, remember, because they have a high melting point.
when you melt this compound, so we're not dissolving it, we're not bringing in some other substance to take this apart. When we melt this compound, what happens to it?
Well, then we've broken apart all these bonds. And I wish we could do this on the board, but all of these things would move away from each other, and the positives would not be so close to the negatives anymore. There'd be a greater separation, and the particles would be flowing past each other a little bit more.
The point being that they're now free to move.
Right.
They're free to move and carry electric current.
Sometimes I show my students the crystal structure with all of these things bonded every which way. And if we're breaking all of these attractions that I drew in blue, then we have these charged particles that can move around, and that's how we can conduct, or it can conduct electricity.
That's right.
We good?
I'm good. I'm ready to take the test.
I think so too. I think we're going to get lost on it.
Well, we've taken it 20 times at least.
At least. Yes.
Yeah.